Hi friends, and welcome to this section where we are going to discuss how to make one thread wait for one or more threads to complete before it continues its execution for both the APIs, of course. In the current video, we will discuss the mechanism for the normal threads API. Now, we have already seen two techniques in the previous sections that can work here. The first one is the isAlive method. To know if a thread is still executing or not, you call the isAlive method on that thread. If it returns true, that means it is still running. If it returns false, that means the thread has completed its execution. But the problem here is that you have to call isAlive multiple times on that thread till you get a false, the confirmation that the thread has finished. This is wastage. Instead, we need a mechanism that informs or signals the interested threads as soon as the thread in question finishes. We should not have to poll that thread repeatedly to know when it has finished. The second technique that we have already discussed is the wait and notify mechanism that we saw when we wanted to return values from tasks running in normal threads. Here, the calling thread gets blocked till the thread for which it is waiting to finishes. We made the calls to wait and notify at appropriate places ourselves in the task that was running in the awaited thread. For the newbies, this mechanism is a little difficult to understand and implement. Now, the mechanism that we are going to discuss in this video is similar to this second technique. The only difference here is that this mechanism is inbuilt in the threads API itself. It is available via the join method on the thread class. The thread that calls join on the other thread is suspended till that other thread finishes. As soon as the other thread finishes, the call to join returns and the caller thread can continue its business then. If a thread has already finished when join is called on it, then join returns immediately. The call to join may be aborted by interrupting the calling thread. So, a try-catch clause is required around the call to join. Let us see this mechanism in action. We are going to create 4 threads and start them. We will use loop task D for our tasks here, as we can control its execution duration. After starting the threads, we are going to call join on them from the main thread and then see the results. So let us put some code here. Here we have coded so that the first task finishes earliest, then the second, then the third, and lastly the fourth one. And after each call to join, we are printing a message to that effect. Let us run this class now. We see that all the threads started executing their tasks, and after that the first task ends first. We do not see any output from the main thread before the first thread ends. This means that the execution of the main thread had been suspended when it called join on the first thread. As soon as the first thread finishes, the call to joining it from the main thread has returned and the main thread has printed its message here. After that, again, there is no output from the main thread visible till the second thread finishes. So this time the main thread has suspended on the call to join on the second thread. After the second thread finished, we see a message from the main thread. Similarly, we have the output here for the third and the fourth tasks as well. And lastly, the main thread ends. Let us change the sleep time for the third task to 500 milliseconds so that it finishes before the fourth one. Running it again now. We see similar output as the previous run where the first and second threads have ended. After that, we see that the fourth thread has ended, but there is no message from the main thread after that. This is because the main thread hadn't even called join on the fourth thread as yet. It was still awaiting the join on the third thread to return. After the fourth thread, the third thread has also ended here, and after that the main thread has printed its message regarding the third thread. Then the main thread has called join on the fourth thread, but because the fourth thread had already finished by that time, the call returns immediately and the main thread prints the message regarding the fourth thread too. And lastly, the main thread ends its run too. That's all I had for this tutorial. In the next tutorial, we will see the third way of returning values from the tasks running in normal threads. In that, we will make use of the technique that we have just finished deliberating. This will be in continuation from the returning values section. See you in the next video then. Bye.